First of all, we're starting with the zip file, CST performance model, Linux. This is a Linux zip from Circuit Sutra. So I unzipped it and created the CST performance model directory, which has a set of benchmarks, README, run model.shell, and various other output directories for running the performance model. First thing that trips people up is you need a boost model. I installed a boost model. I've created a setup that points to a compiled boost model on my machine for this demo. So you source that, and that'll set up the pointer to your boost model. And we can go down into performance model unzipped and look at the README file. And the README file, you can check make sure all the downloads were created properly. And then it has a prerequisite for the boost. And I did that and put that in the setup routine that you just saw. And there's simple commands for running one test. And then it runs the performance model and outputs the CSV file that you can run in the visualizer tool. That's the trace, and then also puts a log file out. We have ran one test, the ALU independent instruction test, data.csv. The setup that I had to do for that was to make sure that the run model sh was executable, and then give it the proper command, which is the run mod sh, and then the test. And then if we go and we look in the outputs, we see traces, we see the instruction data.csv from a Dhrystone run that I had done earlier. And this is the test run that I had just ran, the ALU independent instruction. So this is the output of the trace file. You can feed that into the visualizer tool. And then in the log file, you get the IPC, total cycles, and then various other information about the performance model and some debugging information if there's some errors. If we want to run a more sophisticated model, you can run Dhrystone. The log file obviously was presented to the screen. I could add a log file option and push it out. So this gives us a little more information on more analysis on a higher level benchmark on Dhrystones. We have the IPC accuracy, various stalls. Next, we will load this into the visualizer, and I will show you how to use the visualizer. This is a quick walkthrough of the visualizer. The first thing to do is to point your HTML browser, the IPC Pipeline tool.html. We've already run the first part of Dhrystone. I ran 5,000 cycles and put it in on my Windows machine so I can access it via the visualizer tool. So first step is to select your width. I like 50. And the next part is to browse and put in your location for the output of the performance model in the CSV format. Then press load the CSV. And what you'll see is the IPC versus cycle. And then you see it went up to 2,500 cycles. Then we are sitting at, when you want to click on a piece of, let's say, slow or fast, IPC versus cycle, you just click in the window. There's many tools that you can use over here to move things around. Not really super necessary, unless you want to print some things out. So if we went these sort of look like setup routines more, and then we get more into more loops and things. But just to show what the tool can do, we look at the IPC here, and we're looking at a low IPC, and it shows up as in a pipeline trace, cycles 142 and 181, and it shows the different steps in the pipeline where instructions are and when they retire. So we're looking at cycles across here, instructions and PC are across the bottom. So, and if we want to move on to higher IPC, then you can see things moving quickly through the pipeline. This is more of a debugging tool to figure out where you're at, what you need to look at in terms of what is stalling, what is running, and where you can apply your performance tweaks or correlation with the RTL model. In addition to that, we have an export XLSX button. That button will export the picture of this on your screen to a file on your machine. Then you can bring that up later outside of the visualizer. Thank you for sitting through the video. I will respond to any questions you need. It's Paul at simplexmicro.com. Thank you.